Okay, so let's continue on where we left off on Friday. And if you guys could just put aside any work you're working on and just direct your attention up front here. So I want to pick up here on problem number 2. So in this problem, we want to calculate some mixed numbers. Okay, so again, if you're uncomfortable with working with fractions, please let me know so I can put some extra time into that. But I thought, at least for this one, maybe I could show you how to, for those who forget, how to turn that mixed number into an improper fraction. So we have, for example, with the first number, 3 2/3. Okay? So if you don't remember, the way to do that, okay, with 3 2/3, okay, who remembers? How do we start? Right, you take the denominator and you multiply it by the whole number. So we multiply. So what do we get? 9, right? But we're not done yet. There's another step. What's the other step? Back corner. Somebody. Right. And then add. What's another name for the 2? Numerator. The numerator, right. We add the numerator 2, and we get 11. So is the answer 11? No. What do we do now? That's right. We keep the same denominator. And so we get 11/3. Excellent. You guys do seem to have this stuff down. Very, very good. Okay, so now, if we have 11/3 and we have -7/4, okay, and we're putting those together, what's another way before you look down here, what's another way we could express that other than 11/3 plus -7/4?
3 whole number 2/3.
Well, yeah, we could convert it back. We could also convert it to a decimal. But can we perform this operation right now? Can we actually subtract? Can we actually add the negative? What I was looking for was you could say 11/3 minus 7/4. But you still can't do that either because we don't have a common denominator. So to find the common denominator between 3 and 4, we've calculated at 12. So now we've got the common denominators. And now you could express this the same as 44/12 minus 21/12 to give you your final answer of 23/12, okay? And that, if you want, could go back into being a mixed number, okay? And to do that, to turn this back into a mixed number, you actually do the division. How many times can 12 go into 23? Once. And how much is left over? 11/12, right. So you guys do seem fairly comfortable with that. If you're not, let me know. I'd be happy to put some more time into helping you get there. But that's the kind of thing you could expect in exam questions in this particular section of the math curriculum. Okay, so here's now multiplication. So we're going to have 3/4, 3/4, times -2/3. Now multiplication with fractions is actually, I think, even easier because you don't have to worry about common denominators and stuff like that. All you got to do is straight multiplication. Multiply the 2 numerators, multiply the 2 denominators, figure out the sign of the answer, and you're good. Now, here we're multiplying by a negative. Gee, is there a sentence that could help us remember this? Does anyone remember a sentence from Friday? What's that sentence? A negative times a negative equals a positive. Is that the case here? No, this isn't negative, this is positive. So what's the answer going to be? Negative, right? Because it's not a negative times a negative, it's a positive times a negative. Okay? So we have 3 times 2, and we have 4 times 3. We have 6, and we have 12. The answer, negative. But as well, 6/12 can be reduced, right? 6/12 is the same as 1/2. Okay? And again, that's a fraction reduction right there. Fourth problem, division of fractions. Now, I think division is also very simple because all you need to do with division of fractions is to do what's called the reciprocal. Reciprocal is a fancy word. It just means, well, one way you could put it is flip it and multiply it, right? Flip it and multiply it. So first of all, we have improper fractions. So probably the first step would be to turn these into mixed numbers. That's a way we could do it. And then we'll flip it and multiply it. So there it is. Improper fraction, 3 over 2, divided by negative 11 over 4. Flip it, we get 4 over 11. Multiply it, we get 12 over 22, reduces to 6 over 11. Now in this case, we have a negative divided by a negative. A negative divided by a negative? Positive, right. Positive number. Now, I can say this stuff to you guys all day, but unless you actually practice it, it won't become clear to you, okay? A way you can think of mathematics is very similar to sports, right? Let's say I was your basketball coach, which I know is easy to imagine given my shape and size, right? I'm in shape, round is a shape. If I was your basketball coach, I could show you guys how to shoot a free throw. Does that mean you're now good? I'm good to go? So the game? No, of course not. You want to practice that. Practicing makes it easier and easier so you don't even have to think about it. Let me also draw the analogy to music. My daughter plays the piano. Someone could show her a piece of music. She could have it in front of her. She could read it. Does that mean she's ready for the concert? No, she should practice that. She should practice it until she doesn't have to think about it. Similarly in math, if the test was today, I've shown you how to do these kinds of questions, but that doesn't mean you're necessarily ready for the test. You want to practice it. Practice it until it just becomes something you don't have to think about anymore. In a lot of ways, math is much more similar to sports or phys ed and music than a course like social studies. In social studies, you might be shown something once. You don't need to keep practicing it. But in math, I think it is more the case that you should practice it to get good at it, especially if you're not good at it now, right? Similarly to sports and music, if you're terrible at playing the piano, you should practice even more. And if you're bad at basketball, you should practice even more so that you can perform better. Okay, so let's just throw out a couple quick examples before we wrap up today, okay? The first one, I want to write these numbers in ascending order. Then I want to see which fraction is smaller, this one or this one. Pick a fraction between those two. Calculate this number, calculate that number, calculate, calculate, calculate. So I've got 8 problems here. So let's tackle the first one. Okay, so we got the numbers. I'm going to write them down. You guys, oh, now you're going to test my memory, which is terrible. 0.3, what was the other ones? You guys remember? 0.6, remember the next one. 0.6, and this one was repeating, right? What was the next one? Minus 3 over 4. Terrible short. 1 1/5 and negative 1. Okay, so what should we do to approach this? Well, we have them in different formats. We have some in fractional format and some in decimal format. We could turn them all into one or the other. What do you think? Okay, so which one would you suggest? You want to change these into fractions? Sure. So what would this be as a fraction?
3 over 100.
Doesn't have to necessarily be over 100. 10. What would this be? Negative, right? What about that one? Improper. 5 times 1 plus 1.
6.5.
And that one? Negative 1 over 1. Now, we've got them all as fractions. Can we compare them now? They need a common denominator, don't they? What would be a common denominator in this case? 20. Yeah, we can make it 20. So let's turn this one into 20. We want them all to be 20s on the bottom. What would this one be? 6, right? We'd have to, because we had to multiply this one by 2. We'll multiply this one by 2. For this one, 12. What about this one? 15. Multiplied by 5. This one? 24. Multiplied by 4. And this one? 20 over 20. Now don't forget our signs. This one's negative. This one's negative. This one's negative. Now we've got the chance to place them in a certain order. We've got like numbers here, okay? So which would be, first of all, which ones are below 0? Well, the negatives are below 0, right? So this one is below 0, this one's below 0, this one is just below 0. Okay? Now, we have two other ones. This one's above 0, and this one's above 0. What's the order? Which one is bigger? Right, this one is larger. So this would be our largest. And I'm sorry, which way did it say to put them? I can't remember. In ascending order. So that's from smallest to highest. So this would be the highest. Okay? So out of the 1, 2, 3, 4, 5, this one would be 5th. Ooh. Yeah, you got it. I can't run a circle around it. This one, right here, no, I'm all messed up. Here, we got to get that back on the thing. There we go. This one would be 4th. So now we got the last 3. Okay? What do you think? What order have we got here for these 3? What do you think? Okay, but why?
Because everything else is way too small.
Right. I mean, you can just look at the numbers. 12, 15, 20. 20 over 20 is -1. That's a negative whole number. This is not quite 1, right? Yeah. So then this would be 1, right? This would be 2, and this would be 1, 2, 3. Right? So the order would be -0.6, -3/4, -1, -0.3 repeating, and 1 1/5. Okay? Next question. Which fraction is smaller? -7 over 10 or -3/5? Let's take a look. -7, oh man. -7 over 10, or sorry, what was it? -3/5. Which is smaller? Okay, first of all, can we look at them this way? No. We got to make them equivalent. We got to make them the same. So what do we got to do? We could change the second one to 10, and the top would be 6. -6 over 10, -7 over 10. Okay? So which one, what's the question again, is smaller?
6 over 10.
Is it this one or that one? Which one's smaller? Okay, good, good. Yeah, good. Okay. You guys are kicking on this. Now, I'm not going to, well, I guess, yeah, let's do this one on the board. I'm not going to do this one on the board. This is a calculator exercise. If you want number 4, you could just punch it in your calculator. Most of these are calculator type exercises, but let's do number 3. Identify a fraction between -2/4 and -2 over 2.6. -2.4 and -2.6. But I'm asking you to put a fraction in between. Okay? Well, first of all, let's put these into fractional format. How can we put this one into fractional format? Somebody else, somebody around the room. What do you think? 2 and 4 over 10, that's correct. And of course, we're talking about negative here. And then this one would be 2 and 6 over 10, negative. Okay? So now, you can identify easily one in between, can't you? I hope, if you just look at the numbers that are kind of in between. Here we have a 4, here we have a 6. What's in between? 5 over 10. -2 and 5 over 10, which we could express in a different way as -2.5. This was probably the answer you thought of right away. In between here and here is -2.5. That could have also been directly converted into a decimal there. But look at it in a couple different ways, right? And that's what I want you guys to be comfortable with, is just flipping back and forth between decimal and fraction and improper fractions and mixed numbers. Just be comfortable flowing in all those different directions. Okay, let's divert back to our examples. We'll leave those for now. This is where I started on Friday. Let's wrap it up by coming back to where we started, okay? Here are the key concepts in today's presentation, today and yesterday and Friday's. Rational numbers can be positive, negative, or 0, okay? They can include the integers, the positive and negative fractions, mixed numbers, decimal numbers. All of those are rational numbers. The word equivalent represents the same rational numbers. One strategy for comparing and ordering rational numbers, as well as identifying a rational number between two rational numbers, is to use a number line. I didn't do that in the examples today, but a number line is absolutely a good strategy for doing that. When performing arithmetic operations on rational numbers, the rules for signs apply, as does the order of operations type stuff. So parentheses and bedmas, for those of you who know what that means, all of that applies with arithmetic operations on rational numbers. Keywords. Here are the keywords from the last 2 days. Rational number, decimal fraction, and equivalent. Does anyone need a definition for any of those? Good. Here's the curriculum. This is what it said you guys need to know. Let's see how you do. Demonstrate an understanding of rational numbers by comparing and ordering them and solving problems that involve arithmetic operations. Put in order a set of rational numbers in fraction, in decimal, or place them on a number line. Identify a number, a rational number that is between two rational numbers, and solve a problem involving operations on rational numbers in fractional form, decimal form, or a combination. That's what you guys needed to know. I think you guys hopefully will be there. So let me show you what the assignment looks like for those who haven't seen it yet, and what generally my assignments will look like. Okay, so I'm just going to open this up from my notes, but you have the paper copy, as you always will for this. Okay. Come on, open up. Okay, so here's what you guys are getting. For these assignments, okay, the front page will have a spot for your name. Please fill that in. It's the most important question on the sheet, because without it, I can't give you any points. This part over here will actually be the part where I will put in your scores, okay? The worksheet is scored out of 7. I'll get to that in a minute. The homework section is scored out of 2. That section is the section I was saying that you unfortunately cannot do. And then notes is worth an additional extra point should you choose to do them. Life is about choices, but with every choice comes a consequence. The first part I would suggest for sure is something you want to address, which is solving some of these problems. So I've given you some space on there. Hopefully it's enough space to solve these little problems. What's the opposite of each rational number? Compare them. Which value is greater in those pairs? Which value is smaller in the pairs? Identify a decimal number between each of the following pairs. So it's a bunch of practice. Identify a fraction. But then as you get to the bottom of this page, and you're going to find this on my assignments, you're going to find a homework review section. Okay? In this, I will identify sections of the textbook that relate to what we just did to read, and sections for extra questions to do. You do not need to do this homework part, because if you just do the section above, you'll get 7 out of 10. 70%, that's a great mark. Okay, 7 out of 10, 70% is a great mark. But if you do the homework part, you've got the additional 2 extra points you could tack onto that for up to 9 out of 10. So now you're working at 90% for this assignment, 9 out of 10 for this assignment. But for those who really want the full 10, there's one additional section, and that's the notes. Now, as I said to you before, you don't have to take notes in my class, because attached to this assignment, I've included the notes. Here's all the notes from today's presentation already written out for you. They're there. So you have the notes. In addition, you'll eventually have a textbook with a set of notes in it. Okay? But if you recopy these notes, which further reinforces it, you got that one additional point for 10 out of 10. So it's entirely your choice. If you just do the assignment itself, okay, and here's the rubric. If you do it completely, you get it done, you'll get 7 out of 10. You can get 6 out of 10 if you don't quite get it all finished, 4 out of 10 if it's poorly done, okay, like not fully completed at all, and possibly 2 if you do a couple questions on the assignment. So doing the assignment itself gives you at best 7 out of 10. Doing the homework part as well gets you up to 9, and then doing the notes gives you the full 10. Okay? That's how it works. Okay? Now, this is a bit different because in the past in this course, we used to mark these assignments kind of at a point scale per assignment. But starting with the new math curriculum, we've kind of gone a different route. And I just want to sort of draw you back to the course outline just to show you real quick what I mean by this. It was in the course outline that you saw this, that term work is worth 80%, and the final exam is worth 20. So these points out of 10 for number sense is 10 in that, so this will even out all the assignments. So when you get the second assignment, it'll also be out of 10. Quizzes will be out of a higher amount because they'll be sort of reviewing this stuff, and then unit tests will be even higher. So it kind of figures into the percentage of each of these. Yes?
Because we don't have the textbooks and can't do the homework, does that mean that we get the automatic 2 points?
Does that sound fair to you guys? Do I just get the automatic 2 points? I think that sounds fair.
Okay, that's nice.
Unless someone is in disagreement. Anyone disagree? I think that would work out. I think that would be a nice little way to start the course. Okay, so the rest of the period, and that's about 40 minutes of time, is yours. However, I think since we're now on work time, I just remembered I've still got, that's